A test team from the Development Center, Marine Corps Development and Education Command, was deployed to the Republic of Panama for operational evaluation of the 637K and the 637M antenna systems. This operational evaluation consisted of the erection and disassembly of both antennas in a jungle environment. This technical film report will also portray the conduct of engineering tests performed by personnel of the Collins Radio Company, the contractor and developer of the antenna system. The test team erected the 637M in a dense jungle environment in an area that would normally be used for a regimental or battalion-sized command post. The 637M, with a frequency range 2 to 30 megahertz, is a horizontal or vertically polarized antenna system. It is compatible with Radio Set ANTRC 75 and Communication Central ANTSC 15. In assembling the test site, the team erected a small frame-type portable shelter, also under development by the Marine Corps Development Center. The tent is lightweight and expandable and will replace the Marine Corps CP tent. The 637M is a 200-pound load when packed in its transport case. Testing in Panama in mud, rain, and dense jungle foliage proved the adaptability of both antenna systems to this difficult terrain. Erection of the 637M requires an initial site selection and directions to operator personnel on the guying and lifting of the antenna system. The antenna base plate is placed at the location where the center of the mast will be. The base plate stakes are driven in place, keeping the base plate steady so that it does not shift during erection. The A-frame, the major item utilized in lifting the antenna, is attached to the base plate. The cotter pins that attach the A-frame to the base plate are inserted, and after assembly of the A-frame and its attachments to the base plate, the lifting stake is inserted utilizing a pre-marked portion of the guy line. The lifting stake is inserted by use of a pounding cap that reduces the wear and tear on the end of the stake. This pounding cap was found to be unsatisfactory. The ballam bracket is placed on the special mast section designed to receive it, and the mast sections are inserted into each other. These are coaxial mast sections with an inner and outer conductor providing the transmission line that feeds RF power to the antenna at the top of the mast. Spraying the mast sections with the lubricant was required because the pre-production sections were slightly out of round. The top housing unit, which is the receptacle for the antenna elements, is inserted as the final section of the mast. The elements are then put together utilizing a hose clamp to secure each element to each other. The elements are inserted into the top housing and secured with a cotter pin. During the erection sequence, the guy lines have been stretched out to their respective guy stakes. The ballam is connected to its tie point on the diapole elements, and the lifting hoist is attached to the A-frame and to the lifting points on the mast. The lower lifting guy is adjusted so that the mast is lifted without a bend. Prior to the erection of the antenna, the ballam bracket is firmly seated on a special mast section and the slack taken out of the ballam cable. The antenna is then lifted with a steady motion. Note to the right and left-hand side of the picture the antenna element snagging on tree limbs as it is lifted. And note also that with a constant upward motion, there is no adverse effect on the antenna. The erection was completed with the forward and rear guy lines staked in, but with operator personnel holding the lines on the left and right side due to the thick jungle foliage and the problem of inserting the guy stake in this foliage. After erection, the guy lines are adjusted to remove any bends in the mast. When the mast is straight, the guy lines are secure. The TRC-75 is backed in place and the coaxial cable inserted into the radio and into the antenna. Disassembly of the 637M is an inverse function of the assembly. The guy stakes are removed and through use of the hoist, the antenna is lowered slowly to the ground. When the antenna reaches ground level, the antenna elements are removed and the antenna is disassembled in the reverse order of its assembly. During testing, it was determined that the components of the antenna are extremely rugged and can take the type of treatment that would be encountered in a jungle environment. As the antenna is disassembled, the parts are stored in the transport case provided with the antenna. It should be noted that the antenna transport case was configured so that the antenna components are placed into the box in random sequence. This was found to be unsatisfactory, and a recommendation has been made to compartmentalize the box for easier and more logical storage of equipment. Storage of the various components in the transport case is difficult. In this sequence, the entire antenna system is placed in the box with the exception of the coaxial cable which did not fit. During this sequence, the 637M was dropped on purpose. This drop caused damage to one of the lower antenna elements, a bend in another antenna element, and also caused the mast section to be bent at a very drastic angle. However, this angle was not detrimental to the mast sections, and when erected again, there was no damage indicated. It is significant that the mast section can take a terrific bend without adverse effect. The contact point at the base plate was bent, but was repaired at the site. Extracting the antenna from the trees into which the system fell provided no significant problem, and disassembly was accomplished in a normal manner after the antenna was removed from the trees. Operational test of the 637K, the lightweight 2 to 12 megahertz high-incident skywave antenna designed to operate with the ANPRC-7 radio system, were conducted at the U.S. Army Tropical Test Center at Skunk Hollow, located on the Atlantic side of the Canal Zone. This area consisted of dense tropical rainforest with a minimum canopy of 150 feet and maximum canopy of 200 feet. This jungle area was typical of a platoon or company-size CP, or the type of terrain encountered by reconnaissance patrols in Southeast Asia. The PRC-47 and 637K antenna were hand-carried into the test site for the erection sequence. After arriving at the test site, the PRC-47 was assembled and the 637K was placed on the radio. The special mast section adapter is screwed into the antenna receptacle on the PRC-47. The 637K tune chart is placed over the whip antenna tune chart and the top mast section containing the antenna elements are inserted into the special mast section. This provides a platform for the operator to remove the elements and spread them out. The operator threads the elements through the foliage. This is significant since these elements can rest against the foliage, go through it, touch leaves, branches, trees, with no adverse effect on the operation of the system. Since the 637K radiates in an upward direction, utilizing high-incidence skywaves, the dense jungle created no problem for the system, since the wave path was straight up through the trees, rather than a ground wave through the jungle. The attenuation that a jungle path would normally create was not a factor. Disassembly of the 637K is the reverse of its assembly. The mast sections, which are also a coaxial conductor and transmission line, are taken apart and placed in the canvas carrying bag. The top mast section is again placed on the radio to provide a platform to wind the elements onto. The operator in this particular sequence is retracting an antenna element, utilizing an improper but common procedure. The results of this procedure are apparent. A period of about 30 minutes is required to untangle this snarl of wire. The correct retraction procedure is for the operator to free the element from any foliage or branches and return to the radio, winding the element onto the special mast section as he pulls the element through the jungle. During retraction, it is possible that the elements will snag and catch on foliage and must be freed. After all elements have been reeled in and wound on the special mast section, they are secured by use of a strap and the entire assembly placed in a canvas bag provided. In a jungle environment, the canvas carrying bag becomes waterlogged and accumulates mud and dirt. Rolling of the bag becomes difficult and securing of the straps becomes virtually impossible. A use for the 637M that was not originally intended was as an antenna for the PRC-47. This was accomplished by means of a jury-rigged cable that was assembled at the test site by Collins radio personnel. The 637M and PRC-47 make an excellent combination. During the Panama test, engineering evaluations were conducted by personnel of the Collins Radio Company. A transmit site was located on the shore of Lake Madden in the Canal Zone. Receive sites were located 15 miles away on the Navy pipeline in Gamboa, 20 miles away in Skunk Hollow on the Atlantic side, 75 miles away in Rio Hato in the Republic of Panama, and 300 miles away in San Jose in the Republic of Costa Rica. Data was collected on the input power delivered to the antenna of the radio systems PRC-47 and TRC-75 and were recorded for later analysis. Signals were transmitted from the 637M to the receive site where readings were taken on the field intensity in microvolts per meter and signal to noise ratio readings were calculated. The Empire NS 105 field intensity meter with a calibrated loop antenna was utilized for all field intensity readings. Comparisons were made between the monopole provided with the PRC-47 and TRC-75, the long or sloping wire antenna, and the 637K and 637M. In all cases where readings were obtained, the 637K and 637M proved favorable and outperformed the whip and sloping wire antennas. During testing in Panama, it was necessary to observe and use the maximum usable frequencies as predicted by the Environmental Sciences Service Administration in their ionospheric predictions for the month of November and December. The maximum signal path was 300 miles from Panama to San Jose, Costa Rica. The test site in Costa Rica was located at the home of a member of the U.S. military mission. A PRC-47 with a 637K was utilized as the transmit station. After the signal was initially received on the loop antenna and a reading recorded, the whip, long wire 637K and 637M were compared. As a result of a testing in the Republic of Panama in a jungle environment, it was concluded that the 637K and 637M were suitable for use in a tactical jungle environment and provided more reliable communications as compared to a whip antenna in the same environment. A significant limitation is the requirement to observe the maximum usable frequencies as listed in the ESA ionospheric table. In the high radio frequencies environment of Southeast Asia and the severe frequency restrictions imposed in that area, this limitation may prove to be more of a liability than the benefits accrued through the use of a high-incident skywave communications techniques. Testing completed, the Development Center evaluation team was transported back to Quantico via Marine Corps aircraft.